The story behind the making of the PowerBase is one that was born out of frustration with a lot of clutter in the listening room, none of it really organized in a manner that was able to solve the problems we were looking to solve. We put cones and spikes, mounted the equipment onto sandboxes and bricks and discs and bases and shelves, and all of it was to try and reduce the microphonics induced by the loudspeakers into the equipment. And add to that the fact that we would tack on power filters between the power plant and the equipment. And you get the idea of how this product came into being. We simply built a state-of-the-art isolation base, which is a double platform with a floating 1/4-inch steel plate on the top, and put a one-way gate power filter inside of it. And together, we solved two problems with one elegant solution. Pulling it off and doing it in the way that we wanted to obtain the results we wanted, was perhaps an entirely different matter. I remember the first time I walked into Dave's office, our director of engineering, and said, "We have an idea and we want you to tackle this, but I don't know that we have any experience in designing mechanical isolation bases." Dave smiled and said, "What a great idea. I do. I worked on it on the space shuttle."
The PowerBase product was exciting for me because of some work I've done previously with equipment that launched on the space shuttle up to support the Hubble telescope. Worked on a camera there that had to one, both survive the excessive accelerations in the launch environment, which were up to 7 Gs, and also to be, after surviving that, to be isolated from the thrusters, etc., that are on the telescope, to be able to maintain a solid lock on whatever it was they were looking at in space. And so the marriage of the vibration, mechanical activities, and the electronics in one package presented some challenges that were formidable. And we luckily have some people who have worked with Paul for a number of years and can expand a lot on the things that he comes in with his ideas about. It's clear that he had a lot of experience in dealing with these issues and transferred that easily to our mechanical and electrical designers. Then the challenge is to try and take those ideas and make something real out of it.
This was something totally different for me. When Dave walked into my office, what he proposed was a mechanical vibration damping system that would keep mechanical and acoustic vibrations out of the audio stream. This is something we hadn't really tackled before, and it was an interesting challenge. The way we went after it was, instead of seeking out a specific frequency that we wanted to deal with, we decided to go broad spectrum because that's what one encounters. So we started first with a sheet metal chassis, a light sheet metal chassis, mounted on top of sorbethane spacers that are pretty dense, and this was tuned to 30 hertz, excuse me. And then inside the chassis, what we did was posit a 1/4-inch steel plate sitting on top of soft sorbethane spacers, and this was tuned to a factor of 10 times. This was tuned to 3 hertz. And the idea then was to diffuse all the frequencies between 3 hertz and 30 hertz, the most problematic ones. And this is what I think we've accomplished with the PowerBase.
The challenges with designing this type of device is to let as much of the power through as you can. You want to not block the energy from your wall from getting to your device at all. But you also want to block all the noise from your wall from getting through your device. And you want to block all the noise from your device getting back to your wall. One problem we see in a lot of noise filters, they can filter very well, but they also block the AC power from getting through unimpeded. And that's because they generally have a lot of small wire in there in order to create the filters. We found that it's very, very important to use large wire and keep it as short as possible in order to make sure that your equipment functions as well as it can. So we use inductors with very large wire. We use circuit boards with at least 2 ounces of copper on them, and we double the traces by putting the same conductors on both sides of the circuit board. And this gives us enough copper on the circuit boards to be the equivalent area of the wires that are used.
Some of the challenges we had were just damping the component itself, the PowerBase itself, because of course it's subject to the same vibrations as everything else is. So we've had to come up with a number of damping devices and damping materials, kind of like what you would use on your automobile to keep sound out of it, to quiet it down. People often use a product called Dynamat, for example. It's kind of a tarry substance and it damps the material, and this is what we wound up using in the PowerBase, just to keep the vibrations out of that component itself.
I think the first time that I really got excited about this project was when the engineering group brought the prototype into the sound room, set it down and said, give it a try. The first thing I did was I put the power plant, a P10, which is an 85-pound power plant, onto the base, hooked it up, and very first track I put on was Cantati Domino, which is I believe it's a ProPress recording. It's an old one, but it's got a great massed voice choir, pipe organ in the back, wonderfully large sound stage, and I could hear every single voice in that choir in a way that I don't think I've ever heard before. The separation between the voices was simply something amazing.
There was this separate nature of the electrical from the mechanical, but they both came together with, I would say, the usual good interaction between our design disciplines here to make something that is really pretty cool.